Hello and welcome. Today we'll look at how FortiOS 8.0 can perform packet duplication based on a defined type of service, or ToS value. FortiOS 8.0 adds ToS matching to SD-WAN duplication rules. This provides more granular control by allowing packet duplication to be applied selectively to traffic with a specific ToS value. In this demonstration, we'll use ToS-based packet duplication to improve traffic delivery between our Vancouver branch and Ottawa Hub. This setup is designed to protect latency and packet loss-sensitive applications, such as live video streaming. For security and compliance, internet traffic from the client PC at the Vancouver branch must pass through the Ottawa Hub before accessing the internet. When the Vancouver user requests a live video stream from an internet-based TV server, SD-WAN sends the request to the Ottawa Hub through the primary IPsec tunnel. The Ottawa Hub then forwards the request to the internet through port 1. After accepting the request, the TV server begins sending the video stream back through the Ottawa Hub to the Vancouver branch. Now, as we all know, live video is highly sensitive to packet loss, latency, and jitter. To ensure this, traffic receives preferential treatment across our network. The network devices at the Ottawa site marked these video packets with a ToS value of 0x88. Now this is where our optimization strategy comes into play, as this marking allows the Ottawa FortiGate to identify the video traffic and selectively apply the packet duplication rule. On the Ottawa Hub, we enable packet duplication for traffic matching ToS 0x88. When the FortiGate identifies a matching packet, it sends identical copies simultaneously through the primary and secondary tunnels to the Vancouver branch. Because packet deduplication is not enabled on the Vancouver FortiGate in this setup, both copies are forwarded to the client, where the redundant packets are discarded by the client's network stack or application. If a packet is delayed or lost on the primary tunnel, its copy can still arrive through the secondary tunnel. As long as one copy reaches the client, the traffic can continue without relying entirely on the degraded path. This improves the resilience of the video stream when one tunnel experiences packet loss or high latency. ToS matching allows packet duplication to be applied only to selected traffic that requires additional protection. First, let's examine the viewing experience without ToS-based packet duplication enabled on the Ottawa Hub. The SD-WAN health check results on the Vancouver branch show approximately 30% packet loss and 120 milliseconds of latency on the primary tunnel. Although the tunnel remains available, its performance is severely degraded. Now we'll open the live TV streaming platform on the client PC and start the video stream. After a short delay, we can see the effect of the degraded primary tunnel. Because packet duplication is not yet enabled, the returning video traffic depends on the primary path. The image quality drops, playback begins to lag, and the stream occasionally disconnects. To improve the connection, we'll configure the Ottawa Hub to duplicate traffic matching ToS 0x88. This option is not currently available in the GUI, so we'll configure it through the CLI. The rule uses a ToS mask of 0xFF to match the exact ToS value and sets packet duplication to force. Matching packets will then be transmitted simultaneously through both the primary and secondary tunnels. With the configuration applied, let's return to the client and relaunch the live TV platform. After observing the stream for a moment, we can see that playback remains stable and noticeably smoother, even while packet loss and high latency continue to affect the primary tunnel. The copy arriving through the secondary tunnel helps compensate for packets that are delayed or lost on the primary path. Finally, let's verify the traffic statistics. On the Ottawa Hub, the statistics show approximately 3.6 megabits per second being transmitted through each tunnel, confirming that the video packets are being duplicated. On the Vancouver branch, traffic is also being received through both tunnels. The secondary tunnel is receiving approximately 3.66 megabits per second, while the degraded primary tunnel is receiving approximately 2.56 megabits per second. The lower traffic rate on the primary tunnel is consistent with the packet loss affecting that path. This confirms that ToS-based packet duplication can improve the delivery of selected loss-sensitive traffic without requiring duplication for every traffic class, and concludes our video. Thank you for watching.